In the last lesson, we explored a visual representation of what we did in the previous lessons and what we need to do in the upcoming lessons. But from a coding perspective, there are certain things that we actually have to consider regarding our architecture before we actually start coding out our solution. So what we know is that we need to pull the data on our Firestore collections collection into our application and then store it in our Redux so our application has access to it by using the selectors and pulling them from the appropriate reducer. Now, there are actually two things we need to think about first. The first is that when looking at this data, is this data complete? Does the data represent everything that I need in order to utilize it best for my application? Well, you remember that when we stored our collections data inside of Firestore, we removed the route name property. And the reason we did that was because the data of the route name is not important to the backend because it's only relevant to the front end. In other words, it's only important to our desktop web application what the route name needs to be. If we had, say, a native mobile application that was also pulling in this collections data, it doesn't need that data at all. In fact, that's just simply cluttering up the memory allocation for our database, and it's also cluttering up the data that we're pulling in to other applications that are not our web application. So with that in mind, we know that we need to add this route name property back onto the data that we pull in from Firestore. So that's one thing. The other thing we need to think about is where inside of our application's components tree do we actually want to put the code that will fetch this data as well as store it inside of our Redux. The reason that we have to make this consideration is due to the nature of how the application is set up. Now, if we go to this diagram, let's imagine that this tree represents our components. If you imagine the top level here is our app, let's say this was our header, let's say this was our shop page, this was our collections preview or our collections overview page, and let's say this is the collection page for the individual collections. We know that both these components actually need the data that we are pulling from our collections in our Firestore. So I want you to actually pause the video and think, where, based on this tree, do you think we should put the code to actually fetch that data? So pause the video and think about the answer. Now, hopefully you gave it some thought, and if you guessed inside of this node, then you are correct. The reason we want to put the code in the nearest ancestor to any place in our application that needs the actual data that we're fetching is because we want to only write the code that fetches that data one time. We don't want to write that code in both these places because if we do that, we have to repeat our code more than once, even if they're doing the exact same thing. And by the nature and principle of writing code in a dry manner, meaning don't repeat yourself, we want to put it inside of the nearest parent that will call the code to fetch that data from our Firestore. So let's say for pure examples case, we had a component here that needs the data and a component here that needs the data. Well, the nearest parent for these is actually our top level app component. And for this reason, this is where we would end up putting the code in order for these components to have access to that data. Because when we render the appropriate children, we want to either have that data already loaded or in the process of being fetched. And the way that React renders its components is always when you render this component. So let's say our collection page. When you mount this, you've actually mounted all of the parents as well. And these parents are always going to render first before the child renders. For this reason, this is how we can initialize the data that will fetch the data that these components that our children will need. Also, it allows us to follow this dry principle. So that's the main thing that we need to do. So knowing this node actually represents our shop component, which is where we hold our collections overview as well as our collection page components. So let's start writing the code to convert that code over. Inside of our shop component itself, we need to leverage the component did mount lifecycle method in order to perform the actual fetch. Now, that fetch code is going to look very similar to the code that we already wrote inside of our app.js when we fetched the authenticated state of our user. And the reason we put this here inside of the top level app node was for the exact same reason. Our entire application might need the current user, so it makes the most sense to put it in the component that, of course, will render first at the highest level, which is our app component. Now, inside of our shop component, the first thing we need to do is convert this functional component that is our shop page over to a class-based component. So let's do that. So in order to do that, we actually need to switch this const to a class, and then we need to say extends react.component. We're going to put these squiggly braces, and then we're going to cut this code out. All we need to remember is that we're pulling the match off of the props in our functional component. So we'll get rid of this and we'll copy this bracketed code over. What we're going to do now is inside of our render statement, we are going to return that code that we just had. We're also going to destructure the match off of our props. So we'll do that by saying match equals this.props. And now our component is converted. If you just remember the format of doing it like that, it's very easy to convert from a functional component over to a class component. So now that we have this, we actually need to write our component did mount method. Before we do that, we got to think. Whenever we do this pattern, we know that we are going to end up subscribing to some reference, right? And before we do that, we need to remember that we actually need to also unsubscribe from it whenever we unmount our component, just like we did inside of our app. I'll definitely touch upon this subscriber pattern a little more in a couple lessons from now, because we're going to take a deeper dive into what this is doing. But for now, you just need to know that that's the main thing we got to remember to do, is set this unsubscribe value inside of our class component. So what we're going to do is we are going to write this new unsubscribe from snapshot method. Now, this snapshot is going to be the snapshot representation of our collections array that we're going to get from Firestore. And we're going to fetch that inside of our component did mount method. And the actual code to do that, we're going to leverage our Firestore. So what we'll do is we will pull in our Firestore library from our Firestore utils. So we're going to write import Firestore from Firebase utils. Now that we have this, what we'll do inside of our component did mount is we'll say const collection ref equals firestore.collection and then the name of our collection, which is collections. Now, as you remember, that was the title of our collections collection inside of Firestore. So I know it's a little confusing naming wise, but that's just sometimes how it goes. Now that we have it, what we want to do is we want to get this data. So in order to get this data, we're actually going to use a method on this new collection ref that we've already used before, which is inside of our app.js. If you remember with our user ref, we checked on snapshot. So we're going to use that exact same method, except with our collection ref. So we'll say collection ref dot on snapshot, meaning that whenever the collection ref updates or whenever this code gets run for the first time, this collection ref will send us the snapshot representing the code of our collections objects array at the time when this code renders. Now, we know that inside of what we get back from onSnapshot will be the snapshot object of our collection. But we also know that we want to perform some asynchronous requests because the data is on the actual objects inside of this query snapshot, as we'll see. So what we'll do is we will write an async function, and this function is going to get snapshot as the property. And then what we'll do is we'll simply console log out the snapshot to see what it is that we got back from Firestore. And now if we look in our application, we see that this is the query snapshot. And inside of this snapshot object, we see the docs, which is a property that holds all of these 5 documents as the snapshot that we have. If we actually want the value, we'll have to call .data on them, but we see that the ID lines up with what the actual object's IDs are inside of our backend database. So we know we're getting the right data. But now what we need to do is we need to actually transform this data into the right shape that we need, as well as add any values that it doesn't have, such as our route name. So how we'll do that is we will pass it into a function in our Firebase utils, very similar to how we did it when we wrote this create user profile document code. So what we'll do is we'll open up our Firebase utils and we'll write this new function. Now this function is going to get the whole snapshot. And how we'll do that is we will set up this new const called convert collections snapshot to map, because we want to convert it to an object instead of the array that we know we're going to get back. So what we'll do is we will write this function so that it gets this snapshot object. So this will actually be called the collections. So let's actually write this as a arrow function. And then what we'll do is we will write out this actual transformation on the doc objects that we just looked at, which was that array of query snapshot documents. And we will make sure that we return from this modification the right object with not only the right properties, but also our new route name property. So what we'll do is we will say const transformed collection is going to equal collections.docs. So .docs is going to give us our query snapshot array that we were looking at right here. And what we'll do is we'll say .map on this docs. Now, in each one, we're going to get the document object. And what we'll do is we will pull off the title and the items, which are the 2 properties that we want, from the actual doc data. So you remember we need to, in order to get the data off the snapshot, we got to call the data method. So once we pull off these properties, what we need to return from this is an actual object, right, from this map function that represents the final object representing all the data we want for our front end. So we know that we want this route name that we know we don't have on our backend. And all we're going to do is we are going to call this JavaScript method called encodeURI. This method comes with every JavaScript renderer. And what you can do with it is pass it some string. And it'll give you back a string where any characters that a URL cannot actually handle or process, such as certain symbols, spaces, or whatever that you actually never see in a URL, it will make sure to convert them into a version that the URL can actually read. So we know we need to do this because our route name is a thing that we use in order to route by URL. So what we'll pass in is just the title, because we know the title is going to be pretty much the same string that we want for our route name. So hats, jackets, sneakers, whatever that title is, we're going to also use it for the route name, but we also want to make sure that we lowercase it. So once we've done that, we also want our ID. So the ID we actually don't get on the doc.data, we get from the actual document itself. So this is just going to be doc.id, because the ID belongs on the doc snapshot object, but we want it in the object that we end up storing in our Redux. Once we have that, we can simply pass in our title and items as we've destructured them. And now this is going to be the final shape of the object we want. So let's just make sure to actually console log our new transformed collection. And then let's export this out and use it so that we can actually see if our code is working and we're getting the right object that we want in the end. So inside of our shop component, we are also now going to import that new method we wrote. And what we're going to do is we're just going to pass this into the snapshot. So if we save this and we go back to our application, we see that we get an array of our objects, and there we go. It is in the shape that we actually want. We have our ID, we have our items, we have our route name, and we have our title. So everything is working as we want it to. So now that we have our data in the right shape that we want, and we've put in the right place in our component tree, we need to convert this from an array to the final object map that we were talking about as we had originally had it inside of our front-end application. So we'll do that in the next lesson. So I'll see you in that lesson.